All right, here we are again over at Universal Pinball. So with these WPC 89 games, super common when you hit both flippers, the game crashes and resets, and that's because the power needed to flip both flippers dips the 5 volts just a hair too low, and that crashes the computer. So this game's doing that currently. I want to show you guys here. So it starts to get, it works okay when you just do one flipper. A lot of pinball players, they just flip one at a time, which is kind of how you're supposed to play. But then you get someone that comes into the shop, a kid that just kind of goes like that, and then the game resets right away, like this. See? You hit both flippers at the same time, it crashes. Works totally fine when you hit one or the other. This is a 4 flipper game, which might be part of it. But there's a couple of ways to fix that. There's the right way, and there's the wrong way. So I'm going to show you both of them because why not? All right, here we go. All right, we're going to start with the wrong way because frankly it's much easier if you are not too stoked about doing board work and you kind of just want to get it done quick and dirty. They make these no more resets, and there's like 4 different people that make these. They all pretty much do the same thing. They look like this, and what do? I'll show you where they go, but ultimately what this thing does is it takes the 12 unregulated 12 volts from the game and it turns it into a completely steady 5 volts, and then it uses that 5 volts instead of the 5 volts that's generated by the voltage regulator and the power driver board. Usually, in most cases, it's a bad voltage regulator. If you put this in, uses the 12 volts instead, gives the game the steady 5 volts that it needs to not reset, and it mostly works. I have heard that these can damage the 12 volt side of the power driver board. So maybe I've never had that happen myself. I don't usually use these very often, but if someone calls me and they tell me their game's resetting, but they don't, and I tell them, I got to come out and do the service call, and then I got to replace the voltage regulator. I kind of give them a price, and then I say they don't want to pay that. I'm like, all right, well, you could buy this for 50 bucks and put it in, and it'll probably fix it. So customers do that sometimes, and for the most part, it works. So whatever, if you want to do it that way, go for it. I'm going to show you how to do it that way, and then afterwards I'm going to show you how to just do the voltage regulator, which is actually fixing the problem instead of, this is a Band-Aid. So let's start with the Band-Aid. So we got to take the glass off, like this. I'll turn the game off here while I put this in. Open the door, slide this down. So this, no more reset, 5 volt reset repair. If you Google like WPC 5 volt repair, 5 volt fix, there's a bunch of these. This one was like show the picture. This one was from, where's the picture? Right here. This one was from Pin Sound, which I know Pin Sound sells these. They do. They were a pretty good deal. So that's good. Whatever. If you want to do it this way, sure. So it goes right here. Right here. Pull this out. You can't put it in wrong. It's keyed. Put it in like this. Put it in like this. There it goes. And then it's in. And this one kind of has a cool, it's got some lights that tells you if it's got everything. So I'm going to zoom in on it here so you can see the lights. All right, here we are zoomed in. Remember, it goes into the CPU board. We're zoomed in. We're going to turn the game on. We're going to see what the lights show. So they're all green. So it's kind of hard to read it here. What does it say? This one says 5 volts in. This one says 5 volts CPU. And this one says 12 volts in. So this thing is showing that all 3 are good. Let's make the game crash and see what the lights say. I don't think it's going to crash. See, it didn't crash. I was flipping both flippers. So this does essentially fix the problem. But like I said, it's a Band-Aid. Hardcore techs are going to tell you never do this. I'm not a hardcore tech. So I'm just going to leave that one up to you. All right, we got it in, and we're going to play some pinball. See, now we can play. It's not going to reset. All right, you get the point. So that is a good solution if you don't want to pull the board, you don't want to do board work, you don't know how to do board work, you don't want to pay someone to come out. From what I've heard, it can damage the 12 volt side of the power supply, But if your only option is to mail the board out to someone to fix it or to buy a new board, then if you damage it more, then you still got to send it to someone to fix it. I don't know. I'm not going to advocate either way on that one. But let's see how to do it the correct way, which is actually fixing the problem, so you don't need that little Band-Aid anymore. We're going to check the voltages on the voltage regulator. We're going to see what we see, and then we're going to try to do a reset, see if we can see what it dips to, and let's give that a shot. All right, this is the power driver board where all the magic happens, so to speak. So there's these two red wires that, let's pull this off for now. There's these two red wires here at the top of this connector. This is where the AC comes in. And then the AC, it goes through this second fuse here, which is, what's that? It's called fuse F113, which over here it says is the +5 logic. So that fuse could be blown, but if that fuse is blown, you got 0 volts. That's not going to cause this problem. And then it goes to this right here. And I'm going to show you how to check this top one. There's a way to check it to see if this is good. And then it goes through the top side of this capacitor, which is the positive side, but then it keeps going to this voltage regulator. So I don't think it actually uses this capacitor to get to the voltage regulator because it just kind of touches here and then touches here. But I had a case not too long ago where somebody had replaced this capacitor and they broke the trace from the top side of the board to the bottom side of the board. It's called an eyelet. Super common to break those if you do these capacitors. So the voltage wasn't getting from the bridge rectifier to the voltage regulator at all because it was getting lost right here at this capacitor. And when I pull the board, I'll show you on the back how we can test for that. But if you're getting close to 5 volts, then you know the voltage is at least getting to the voltage regulator. If you're getting completely dead zero, nothing, then you might have another problem. So here we get our test leads out. So this one, for this board, the test for the ground is this one here. It's often not labeled. I want to say it's test point maybe 5, but it doesn't have that printed on it. It's right under test point 7. So you don't want to do test point 7. This one's the test point for ground on these WPC 89 boards. And what else are we concerned about? We're concerned about the 5 volts. So here's the test point number 2 for 5 volts. So we're going to put the second lead on there, right? So we're going to get our meter out. We're going to go to volts, and this is DC. Comes in as AC, goes through the bridge rectifier, which converts it to DC. And the output of the bridge rectifier is not a super clean 5 volts, which is what the computer needs to see. It's more of an unregulated rough voltage, anywhere from like 8.5 to 11 I've seen. I'll show you how to check that next. But then it goes to here, and it should come out a total clean, pretty close, like super close to 5 volts. So anyways, DC, we're going to put it on 20 because we're trying to check 5. So let's go ahead and turn the game on and see what we get. I got to click. All right, now we're going to turn the game on and see what we get. 4.9 is actually pretty good. So let's see if I can make it crash and see what does it show if it crashes. I'm going to just zoom in on the meter here. I'm going to start a game, and I'm going to, oh, you can see everything. All right, here I'm going to start a game, and I'm going to make it crash, and we're going to see if we can see what it dipped to. Oh, I have my regular, oops. I still have the cheat in, so we got to remove the cheat real quick. Band-Aid, let's take the Band-Aid out. Take the Band-Aid off. And we can make it crash and see what the voltage spikes down to. Dips down to, rather. All right, we're turning it on. We're seeing 4.8, which is on the low end, but it probably would be fine if it didn't dip any below that. So let's start a game. That's not resetting. not super exciting. Sometimes it is just a connector, and it's not actually a problem with the game itself. I think in this case it might have just been a connector. Sometimes pushing on all the connectors is what fixes this. So I guess I'm going to have to just kind of show you what I would have done if it was resetting still, which it is not currently doing. All right, well, anyways, so this is the voltage regulator, and they make a new one, Easy SBC, that you put right in there, and that should give you the solid 5 volts that you need. And that's about all I got on that one. I'll show you how to check the voltage coming out of the bridge rectifier. There's something we can do. So we leave the test point on ground. So right now I'm trying to make sure the voltage coming out of the bridge rectifier is what we want to see. So the way this bridge rectifier works is there's 4 connections. So there's a positive, there's a negative. It looks just like this, it's the same one. So there's 4 little posts coming out of it. There's a positive, there's the negative, and then there's AC and AC. And AC are not, there's no polarity on the AC, they can be reversed or whatever. But you get the 2 AC, it comes in, and it runs it through diodes to convert it to DC, and then it comes out of this tab. So if we put our clip right here on the top left tab of this bridge rectifier, we should be able to see the voltage coming out of the bridge rectifier. All right, I got it on there. So let's turn it on and see what we got. So we got 9.8. That's super solid. That's what we want to see. Anything below like 7, even below maybe 8, is getting to be too low. But that tells me right now that the power AC is coming into here, is going through the 5 volts, is getting to the bridge rectifier. It's coming out of the bridge rectifier as the right voltage. So from there, goes through this capacitor over to this voltage regulator, and this test point is just directly wired to the output of the voltage regulator. And let's see if it's going to reset. We fixed it, I guess. Yeah, I fixed it. So I didn't even need this. All I needed to do was reseat connectors. And I mean, I'm gonna post this video anyways, because a lot of the times that is the fix. Is just start reseating connectors, because something is just sitting, some connector has been sitting in the same place for too long, and whatever it's touching is a little bit corroded. And sometimes just unplugging and plugging it back in gets it either in a slightly different spot, or it cleans it a little bit, and that fixes a lot of the problems on these games. Just reseating connectors. That's not so you do want the power off when you're putting this lead on, because you don't want to short stuff. But let's go back to the 5 volts here. Well, pretty solid. I mean, 4.8 is about as low as you want to go. As long as it's not dipping below that, then we're looking good. In this case, it was connectors, and we fixed it. Good job. What else can I tell you about this board? That's I can tell you an example. So I was actually doing a service call the other day on a Popeye Saves the Earth, and immediately this fuse was blowing, right? So I traced the output of this fuse. I ohmed it to all the different bridge rectifiers because I didn't really know which one it was. Turned out it was this one. So I could ohm from this is the input to the fuse, this is the output, is this one, the output to the fuse. So I ohmed from here to this bridge rectifier, and I was able to find out that this bridge rectifier was shorted, and that was popping this fuse immediately. So that was kind of fun. Well, let's go look at the bench, and I'll show you a little more about this board while we're at it. But my plan was going to be to replace this voltage regulator, because when like I said, when this starts going out and it just dips a little low, that causes crashes. A lot of people put these in because it steadies the voltage so it won't crash anymore. But the real fix is going to be usually, especially if you can confirm you're getting like 4.6 or 4.7, that's too low. If you can confirm that, then you know you got to replace this voltage regulator. They're really not that hard to replace. So we're going to go look at the bench and I'm going to show you how we would have done that. All right. All right, here we are looking at the solenoid driver board. Sorry, they call it the power driver board for WPC 89, which is a lot of games. It's Demolition Man, it's Twilight Zone, it's Addams Family, you know, all those early 90s to like 95, all those top Williams Valley games. Upstairs, I was working on Judge Dredd. Anyways, this board is used in a lot of games, is the point. So I want to show you kind of how we can figure it out. The 5 volts is common to have 5 volt issues, which is what I'm covering today. There's a lot of problems this board can have, but the 5 volt one is what's going to either prevent your game from booting or causing the kind of crashes where you hit both flippers and the game crashes. That's the 5 volts. This is the 5 volt voltage regulator. So AC or alternating current comes in through these 2 pins, and then it goes through this fuse to this bridge rectifier. Now here's the bridge rectifier that this game uses. I want to show you here. They're pretty standard, but this game uses this bridge rectifier. So if you notice, it's got 4 pins. One of the pins is kind of in the middle there and not all the way on the edge like the others. That's the positive out. So it actually has a plus here. That's the positive. So that's the positive output. The other side is going to be the negative, which is ground for the direct current. And then this is AC. See if we can show it here. This is, come on, focus. Focus. What if I do it this way? No. Anyways, I know it's not super focused, but that says AC. This one's AC. And then this opposite corner of it are also AC, not labeled, okay? AC, AC. And then the out, so these are the inputs, the 2 AC inputs. This is the negative, the ground for the DC. And then this is the output positive for the DC. So that's how these voltage regulators work. And you can test them. You can test your voltage regulator. So how do you do that? You put it on diode test, and then let's see here. So I think it's this way. No, it's this way. All right. So see, I have. So this is the negative side. I'm putting the positive, the red or the positive lead to, and then the ground. I'm looking at. This is AC, one of the AC sides, and this is the other AC side. So if you get 0, 0 doing this, then you got a bad one. And then you do the same way this way. And so what you're measuring is voltage drop. Where's this way? I'm not great at testing these. There you go. So this is, you're checking the voltage drop through the diode in the rectifier. And if you get 0 doing it this way, so you're putting the black here, testing here, and this is the positive output. And then if you turn the thing around, I know this is confusing, but put the red here, and then black here, you're testing the diode voltage drop here. So this one's good. And that's how you test it. All right, so I got a shorted one here. I want to focus a little more on how to test these. So let's do this one. This way. So this one's good this way. And this way. Good this way. So this is with the positive lead on the negative side of the DC output for the bridge rectifier. So now I'm going to put the ground lead on the positive side of the output for the bridge rectifier. Remember, this is alternating and this is alternating, so these 2 are the inputs. So see here, this side, that looks pretty good. But then when I do it this way, oh, see, that's way too low. See, that's a short. So I know for sure this is bad. It's got a short in it. So for example, this is the same orientation, right? We got the two. This is the plus, and this is one of the ACs. So if I do it this way, see I'm getting 4.6, which is a healthy voltage drop across the diode. If I do it this way, I'm getting, see, this is a bad bridge rectifier. And that was what was blowing the fuse right away. And I just, you know how I knew it was within the board is because I disconnected everything except for the power input, and the fuse was still blowing. And I'm going to show you how to do that too. So anyways, that's how you can test a bridge rectifier. Once you got a confirmation that it's bad, you know you're looking good. So they're pretty easy to replace. Okay, I'm back to this board. So these are the two pins for the input of the AC. Go through this fuse, go to this bridge rectifier. So I want to show you here. So this is the top pin, and this is pin 1, and this is pin 2. So I'm going my meter over to ohms here. So I want to show you here. So this top pin goes through the fuse, and the fuse is good because it's getting to both sides of the fuse. The bottom pin doesn't go through the fuse. So only the top side of this goes through the fuse. But both of them go to the two sides of the voltage regulator. So this is the voltage regulator, this top one here. That's the one earlier we were clamped to right here. You see that? We were clamped to this top spot here. That's where we were clamped to earlier when we were checking the output without removing the board of this bridge rectifier. That's the positive side. So this is the bridge rectifier. I'm going to put this here so you can see how you got the three corners are kind of normal, and then the positive is pushed down a little bit. So it's like this one. All right, so this is... All right, sorry, my phone got full. I had to delete some to make room for more videos. So to recap, this is pin connector J101. This is where the AC comes in, goes through this fuse, comes over here. So you can actually see, if you can see these traces, this trace goes directly, this is pin 2, this is pin 1. Pin 1 goes over here to a fuse, goes through the fuse, goes to the top side, AC side of this bridge rectifier. This pin goes over here, goes directly to this bottom side of this bridge rectifier. So this one goes here, this one goes here. We should be able to ohm that out and confirm it's getting there, which it probably is because they're big fat traces and we can see them. So this one's getting here, good. Pin 2 is getting here, good. So now we got both of the AC sides of the bridge rectifier confirmed. Ground is good, we're getting ground. And then the positive output of the bridge rectifier goes to capacitor 5. It just passes through. This is the output of the capacitor 5. That's not used in the voltage regulator. It just comes to the top. This is the ground, the positive side of capacitor 5, and it just passes through. So this is where the eyelet can be a problem because it comes in from the top side of the board and then it goes through the hole to the bottom side of the board. So I had a case where the voltage was getting lost, everything was getting lost here because it wasn't making it from the bottom side of the board to the top side of the board. But if you confirm that you're ohming, you're checking the resistance of the output of the bridge rectifier and the input of the voltage regulator. Now I'm confirming that we're getting from the bridge rectifier to the voltage regulator. And stop it. And we did the test earlier where we put one side of our lead on the positive output of the bridge rectifier, and then the other side on the ground. We did this earlier in the video and we got about 9.5. So we confirmed that the bridge rectifier is good, and then we just confirmed that it's getting from there to here. So now here's the test point for the 5 volts. Since we've confirmed the bridge rectifier is good, and then it's getting from the bridge rectifier to the voltage regulator, if anything, if this test point shows anything other than 5, then we know that you got a bad voltage regulator. If it says 4.6, that's bad. If it says 0.02, that's bad. If it says anything, you can probably get away with like 4.8, 5 to like 5.1 or something like that. You're probably okay. So this is the test point here for the 5 volts. Now I want to show you when we turn the board around, that test point just goes directly to the output of the voltage regulator. The meter turned off. So we go from the voltage regulator to that test point. So if you're not getting from the test point to the voltage regulator, then there's a break somewhere else. But if you are, if you can ohm that out, then your problem is the voltage regulator, which it was my intention to show you that replacing this voltage regulator was going to fix the reset issue that we had, but the reset issue went away by resetting connectors. But this is what the modern voltage regulator looks like. It's LM323K, which is an obsolete voltage regulator. This company, Easy SBC, makes this cool little chip here that you put in, and it's got a little pot potentiometer here. You can turn it to get your dial, you get your 5 volts dialed in just right. You don't need the heat sink anymore once you put this in. So all you gotta do is you gotta unscrew the 2 screws there, and desolder these 2 tabs, and then put the new one in, and you fixed your 5 volts. That's the right way to do it. The easy way is to put that little Band-Aid board in that I showed you, but the right way is to replace the voltage regulator, which is what we got right here. A lot of people say do all the capacitors. That's not usually what fixes it. Usually it's the voltage regulator. Doing all the capacitors probably just increases your chances of breaking these eyelets, which can cause you all kinds of problems. So I would recommend against just shotgunning capacitors. The voltage regulator is probably your problem if you were having random resets, or if you were seeing anything other than 5 volts right here, and you confirmed the output of the bridge rectifier is between like 8.5 and like 11. No fuses are blown, and then it's that. All right. All right, here's the board we were just looking at. Now I want to show you to test the 5 volts. All you need is this plugged in. And so all these plugs down here go to the coils and the switches and the lamps. So if you have a short and you're blowing, earlier I was blowing this fuse, and that's the secondary solenoid fuse. Often that's because of a shorted coil, but I unplugged all of these, and all these, and this still blew every time I turned the game on, which told me 100% it ended up being a short in this bridge rectifier. It told me 100% it had to be in this board because everything else was unplugged and it was still blowing the fuse. So it's good to know how to test one of these boards without having everything plugged in so you can isolate a problem. Even if you're going to send the board out for repair, it's good to be able to confirm that the board was the problem before you send it out. So, like I said, to test the 5 volts, which is all I'm testing right now, all you have to do is have this plugged in. And because remember, these 2 were the AC and the 2 red wires. So I'm going to do that right now. Oop. All right, so all you got to do is take this red wire here, plug it in. This is connector J101 with the 2 red wires, 2 AC inputs. So all you got to do is have that wire plugged in. You don't need any other wire to test the 5 volts. I got my leads on the 5 volt test point and the ground test point. So I want to show you here. So that's 4.9, that's solid. That means this board is, the 5 volts for this board is good. I can't tell you the rest of the board's good, but I can tell you the 5 volts are good. So what happens if we're not getting any input to the board? So how do we test to make sure the AC coming into the board is working? That's a good question. Put the meter to AC, which is the squiggly line. It's alternating. And then you just touch them to these 2 wires, these 2 reds. And then you see what the AC input voltage is. And if it's not right, then it could be the problem with the power coming into the board. Maybe it's not the board. So I'm going to go ahead and just turn the power on. What do we got here coming in? Is this the way? You want to go to ground, right? All right, so we put one on ground. One of the leads is on ground. We're going to check. Now we're going to check this. What do we got? Very good. Oh, we got it. Sorry, give me a second here. Get it. All right, so the top one is 5.1. The bottom one is about the same. So this confirms that if you got 5 volts coming in on each one of these, then that should be good because this board's working. So we got 5 volts here. If you don't have 5 volts, then maybe your transformer plug came undone in your cab, maybe your main line fuse is blown. It's not the board. You got to have the 5 volts coming in to confirm that it's the board. So if you don't have 5 volts coming in, it's time to look under the playfield. Did a connector come loose? Did the main line fuse blow? What's going on? Is the game plugged in? You got to make sure you got the 5 volts coming in on these 2 reds. And then we can confirm this board is working. Oops. Go back to DC here. Got the 5. It's a good working board. Yeah, this board, it's important to know how to check the 5 volts. Like I said, the 5 volts is the heartbeat of the system. A lot of problems happen if you don't have a good 5 volts, and this is how you do it. And that's about all I got for this one. When you're checking the board like this, it's very important to make sure you don't short anything out. Be very careful. I got it resting on the pad here. That is, the power can't go through there. I made very careful. Made sure, very sure the back is not touching anything metal. You can cause yourself a lot of problems if you turn this board on and start shorting things out. You might want to put a piece of cardboard or something behind the board. Be very careful not to short anything. That's my PSA. If you short things, you're going to have problems. But if you're careful, you can test a board like this without shorting anything. By just plugging that board in, we got the meter. So yeah, don't short anything. And if you do, it's not my fault. I have a disclaimer. All right, final recap here. Let's turn the game on and see what we're supposed to see here. That's what you should see. So, the transformer voltage comes in through these red wires, should be 5 at each of them. So if you put one lead on the ground and the other lead on the top, you should get 5, and on the bottom you should get 5 on these 2 reds. Goes through this fuse, goes through this voltage regulator, this bridge rectifier, passes through the positive side of the C5, goes to the voltage regulator, gets to this test point here, and then it leaves the power driver board through this connector, and then it enters the CPU board through this connector. So I think the problem was that this connector wasn't making a good connection, so when I reseated it, it fixed my reset issue. I think that's all I needed to do. So I want to show you these lights are important. So when you first turn the game on, this light and the top and the bottom lights are on, and the middle light's not blinking. And then once it boots, you should start seeing the middle light blinking. So if you're getting the top and the bottom lights and no middle light, then your problem's probably in this board, which is common as well. See, once it boots, the middle starts blinking. So that's good to know. But yeah, comes in from here. This connector can also be bad too, which means the power's not coming in healthy. So sometimes you reseat. The first thing would be to reseat this connector, reseat this connector, reseat this connector. On some games, between the two is a little interconnect that you can reseat the interconnect. This game doesn't have that, but you'll see it like right here if it has it. It comes out here, goes in here, and then the CPU boots. So we're going to start a game here, and we confirm that it's no longer resetting. Now the coin door's open. So we're not getting any resets. It was just a connector issue on this game. But it's very good to know to confirm that your 5 volts are good on this game, because it's a very common problem. It can save you a lot of money. Gives you the satisfaction of feeling like you fixed the game by doing what we went over here today. Alright, so on this board we went over the common 5 volt problems that these pinballs can have. It's very common for the game to do a hard reset when you start playing it, once you start flipping the flippers. That is exactly what we addressed almost every time. That's going to be why. It's mostly going to be that voltage regulator, but you can confirm by checking how we showed you. I spent a lot of time talking about that driver board, which is a very important board in this game. There's a lot more to that board. There's transistors. If you have a coil that's not working, it could be a transistor on that board. If you have lights that aren't working, a lot happens in that board. But we were just covering the 5 volts today, and we confirmed the only issue with this game was that we needed to reseat connectors. So we did that. We fixed it. We didn't need to replace anything on this game. I did show you that daughter board, or the Band-Aid fix board, 5 volt Band-Aid fix. That's another way to go if you're just trying to get it done and you don't want to pay anyone. Just order it, you stick it in there. You don't need any kind of mechanical ability to do that. You don't need to know the game at all. You just put it in there. Can cause problems, but I have not personally seen it cause problems. I have heard other people say that it can cause problems. So yeah, but we got this thing working. Now resetting, love it. All right, keep flipping.